32. For triangle ABC shown below, base AC has length of 16 inches and altitude BD has length of 8 inches. The area of a certain square is equal to the area of ABC. What is the length in inches of a side of the square? Okay, so here all we need to do is think about the formula of the area of a triangle versus the formula of the area of a square. So if we want to find a square that has the same area as this. So let's find the area of this to begin with. So the area of a triangle is equal to 1/2 base times height. So in this case, that's going to be 1/2. The base is 16 and the height is 8. So that is equal to 64. So we're looking for a square that has an area of 64. So what's the equation for the area of a square? Area of a square equals side times side, or side squared. So if we set these equal, side squared equals 64. We take the square root of both sides and we get 8. And that is our answer, which corresponds to G. Alright, 33. So we're going to look at 33 through 36 together since they're referring to the same diagram. Alright, so in the figure shown below, ABCD is a rectangle, EFGH is a square, and CD is the diameter of a semicircle. Point K is the midpoint of CD, point J is the midpoint of both AB and EF, point E and F lie on AB. The three given lengths are in meters. So I've summarized this information for you guys here. Let's start with 33. So 33, the length of EH is what percent of the length of AD? So let's look at these two lengths. We know that ABCD is a rectangle, so BC is going to be equal to AD. So we know that the length of AD is equal to 12. Okay. Similarly, we know that EFGH is a square. So that means that all the sides are equal. So EH is going to be equal to 3.6, the same as HG. So now all we need to know is what percent of, the length of EH is what percent of AD. So we're going to put 3.6 over 12 to make a ratio, and if you can put that into a calculator, you can see that the answer is going to be B, 30%. If you don't have a calculator, a good way to think about it is that 3.6 is in between 3 over 12 and 4 over 12, and you know that 3/12 is 25%, and you know that 4/12 is 1/3 or 33%. So you know that your answer is going to be in between these two values, which makes sense because B is the only answer possible in between those two. So that's one way to figure it out. Okay, 34. What is the length in meters of JD? Okay, so JD is, imagine we're drawing this line here from J all the way down here. So we're making this triangle. We can draw this here, A, D, J. So once again, we know that AD is 12, and we were given here that J is the midpoint of AB. So we know that AB is equal to 10. If J is the midpoint, that means that AJ is equal to 5. So now all we need to do is use the Pythagorean theorem, which states that for a right triangle, which this is, since this is a rectangle, a squared plus b squared equals c squared, where c is the hypotenuse. So we're looking to find c, which is this side here. So 12 squared plus 5 squared equals c squared, which gives us 144 plus 25 equals c squared, or 169 equals c squared. Take the square root of both sides, and the square root of 169 is 13. So side length here is 13, which means that our answer is going to be F. Okay, 35. What is the length in meters of arc CD? So CD is this right here. So CD is part of a semicircle. So let's think. You don't need to know how to find arc length here. All you need to know is how to find the circumference of a circle, because this is just half the circumference. So the equation for that, circumference equals pi times diameter. And look at that. In our information that they gave us at the beginning, it said that CD is the diameter of a semicircle. So because we know that CD is equal to AB, and AB is equal to 10, we know that CD is equal to 10, which is our diameter. So the circumference equals pi times 10. Now we can't forget that we just need to divide this in half because it's only half the circle. We're going to divide the whole thing by 2. So the arc length CD is equal to 10 pi over 2, or 5 pi, which corresponds to B. Okay. 36. All right, let's talk through this. The figure will be placed in the standard XY coordinate plane so that K is at the origin. AB is parallel to the x-axis, and 1 meter equals 1 coordinate unit. Which of the following values could be the y-coordinate of H? Okay, so this question sounds tricky, but it's just asking us to imagine something. So say we set this K as the point 0, 0 on the coordinate plane. That would give us our y-axis here, y-axis, and our x-axis here, roughly, because we know that AB is parallel to the x-axis. Okay, so what it's asking us to do is to find what could be the y-coordinate of this point H if it was in this coordinate plane. So if you can think of it like a triangle. So once again, here we go. So if we had the point here, we just need to find the distance from the x-axis to H to find our answer. So to do that, we can take this triangle, or this rectangle again here, which we know is length 12, and subtract 3.6, which we know is the distance between E and H, which would give us a y-coordinate of 8.4 for H. So that corresponds to H. Perfect. So that's our answer for that one. So basically just thinking about distance here, and don't get alarmed when you see a lot of text, because in the end that problem ends up being pretty simple. Okay, 37. What is the length in coordinate units of the altitude from C to AB in the triangle ABC shown in the standard XY coordinate plane below? Okay, so just to clarify, the altitude for a triangle is a line segment through a vertex that is perpendicular to the line containing the base, which is opposite the vertex. So in this case, we start at the vertex, and we're going to draw our line perpendicular down to our base. So that line here is just the altitude. So now we need to find the length of the altitude. So we can see here that points A and B of the base have the same y-coordinate, which means that this triangle is sitting parallel to the x-axis. So, aka this is a straight line. So we know that all we need to look for here is the difference in the y-coordinates. So all you need to do is 4 minus 1 is equal to 3, which corresponds to answer A. if this wasn't flat, then you would need to use the distance formula and a bunch of other yucky stuff. But luckily, because this is parallel, we can simply subtract because this is a vertical line here.